Right, I mean it's 3 o'clock. So, welcome to the cross-distro on BoF. I'm Steve McIntyre. I've been doing Debian development for quite lots of years. I'm currently employed by ARM. I'm working in Linaro. Lots of hats, lots of things. I know some stuff about ARM. I hope you lot do as well. Let's see what we can talk about. So, ARM Linux is a good thing. I'll want to talk about the hard float ABI because a number of people have been asking me about it. I thought we'd already pushed the message out. I'm happy to do it some more. If we can see where the different Linux distros are up to with our ARM ports. I mean, some of us have been doing it for years. Some have just started on it recently. And it would be lovely to get working together. So, why do we have ARM Linux? Well, because it's good. I'm assuming most of the people in the room here like Linux. Many people in the room here probably like ARM. They work really, really well together. Who's involved? ARM themselves now have quite a large team of software people, many of whom are working on Linux and free software. There's the new-ish non-profit group, Linaro. Has anyone here not heard of Linaro? Okay, I'll explain. Linaro is a consortium started by ARM and some of their silicon partners about 18 months ago now. And their stated goal is to work together to make Linux and other free software work better on ARM. In much the same way as ARM hardware is shared amongst all of those silicon partners. You know, they come to ARM and license CPU designs because it's easier and cheaper to do it that way than to invent everything themselves. This is a brand new, fascinating idea of, tell you what, let's work together on the software for the betterment of everybody instead of everybody doing all of their own Linux kernel ports, all of their own distro development. It seems to be going quite well so far. ARM, Samsung, Texas Instruments, Freescale, IBM, and Canonical are amongst the many companies you'll have heard of. There are quite a number of other companies involved at various levels in Linaro, and we do a load of work basically in the open source model, work from home, working in offices, but mainly communicating by email, by IRC, and just working on cool stuff in the Linux environment. It's great. We've got our next big get-together starts tomorrow in San Francisco. I'm going to be flying out there tomorrow morning. We have 4 of those every year. There's lots and lots of cool stuff going on. Linaro.org if you're interested. Where are we up to? We have, in the past, there hasn't been a huge amount of interest in ARM for generic Linux distributions. That's becoming less and less the case as time goes on, as the newer ARM CPUs are that much more powerful and capable of running the full standard Linux software stack. It used to be the case that, of course, people knew ARM CPUs were in mobile phones, but the mobile phones were always running some very specialized software stack, which typically most end users would never even know about, let alone be able to work on. In the next few years, you're going to see ARM CPUs in everything, all the way up from smartphones, desktops, hopefully notebooks, and servers. There's a lot more use and a lot more, demand now to have generic Linux distributions running on ARM. That's why I'm here. So, the hard float ABI. ARM in the past has suffered from a variety of different standards in terms of how software works. I'll go through the details very briefly. I don't want to bore people. Please shout if you think I am. In the dim and distant past, the first really common ARM Linux ABI assumed that always your ARM CPU would have a floating point unit, although that was approximately never the case. It's a really good design. So when you ran software that depended on floating point operations, the kernel would have to catch an exception for an illegal instruction, spend loads and loads of CPU cycles and therefore time fixing up the exception state to work out what instruction you just tried to execute, emulate that instruction, and then return back to your userland program. That did work, but by God was it slow. So we moved on to a newer version, a newer design of ABI for ARM, quite a number of years ago, called the eABI, which actually allowed for use of hardware floating point, but by default didn't expect it. So this is a much more sane way of working. In case you didn't have a hardware floating point unit, you would copy all of your floating point arguments and return values into and out of integer registers. So emulate floating point hardware in userland without having to take the kernel exception cost. It was good, it was fine, and people were generally happy with it. So we get forward to today with the latest version of the 32-bit ARM processor, the V7. Actually now, everything does have hardware floating point. Not absolutely everything. It's still possible to do a V7 ARM without, but again, approximately nobody does. So we've now got this ABI that's designed and optimized for a software implementation of floating point, even though we now have a hardware that makes that obsolete. The cost of doing the copying, so if you have a function call into a library at the moment that does floating point arguments, you end up having to copy all of the arguments from the floating point register into floating point registers into integer registers, do your call. In the function call, in the callee, you have to copy them out and back into floating point registers, do all the whatever work you wanted to do, which might just be potentially a single instruction. When you finished, copy the result back into the integer registers, return to your caller. The caller then has to copy the results back out of the integer registers into the floating point register where it was working on them in the first place. So that's 4 complete copies of all of those. That's not very efficient if you don't have to do it. So what we've done with the hard float ABI is purely and simply say, well, let's use the floating point registers. It's really good. Performance depends very much on your workload. If you're doing a whole load of integer calculations, if you're just doing a compiler run or typical general code, you may never see any benefit from this. It's we'll admit. If you're doing things like Povray, the renderer, that's a particularly good example of a difference it can make. It's very recursive, using floating point everywhere. We have benchmarks that show that you can see like a factor of 3 or even 4 times performance speed up doing the hard float. That's a really big win. Now, of course, that's one extreme. What we're finding in terms of more general benchmarks is that current graphics libraries, GTK libraries and related stuff, actually can see 15, maybe 20% performance improvement on common cases. Because, of course, they're passing around floating point values internally. It makes a lot of sense to do this. On the desktop, it might not sound like much, but 15 to 20% performance improvement actually can be really quite noticeable. It means that moving windows around, starting programs, everything can actually be noticeably quicker. It feels smoother. It's good to have. Performance is the reason we started the ARMHF work. However, the thing that's actually really now driving it forward is standardization. Over the years, we've had many different variations on a theme in the ARM world in terms of how people build their programs. And for devices like cell phones, where you're going to ship one drop of software with the device, it's never going to be uploaded, it's never going to be fiddled with, nobody wants to be able to tweak it, that's fine. But of course, now if we're getting to the stage where we want ARM devices to be general purpose computers, whether they're servers or desktops or whatever, it now helps if you can actually have one style of software, one set of standards, so that your binary from any one of those machines will work on any other. Obviously, modulo, you're actually having libraries installed and so on. But at least this way, we want to have one standard ABI going forwards. Specifically, the most common thing, and again, you'll have seen this in the press and whatever, ARM servers are coming real soon now. People who want to run ARM servers in the data center will want to have the choice of installing Debian or Red Hat or Ubuntu or SUSE. And they'll also want to be able to go to their preferred software vendor to go and install whatever other binary programs are available to be able to run their business. Without having a standard ABI, then again, you would have to have a completely different build for each different distro, at which point now the ISV market would never take off. We want to get something standardized. So, moving on, and I'll get to your bit in a moment. In Debian, we've had 3 different ARM ports over the years, just basically following exactly the same ABIs as I've already mentioned. We had the original ARM port, which supported ARM version 3 upwards, using the old ABI. ARM Linux GNU is the standard GNU triplet that describes that port. And that worked very well. We did it for a number of years, and it's now dead. We then moved on to ARM-EL, which supports v4t, which is version 4 of the ARM processor, including thumb instructions, and using the new eABI, as I mentioned earlier. So that's a soft float ABI, and there's the GNU triplet to go with. And then just literally in the last couple of months, we've got ARM-HF, which is the new hard float version of the eABI, and using Thumb2. It's targeting ARM v7 processors, so that's anything that most of the big vendors are now selling. So all of the Panda boards, Beagle boards, the Freescale IMX series, the latest ones, are all ARM v7. It's, the Cortex A8, Cortex A9, all of the current work in ARM is ongoing on new versions of these processors. So we've come up with a new GNU triplet, ARM Linux GNU eABI HF. I'll just say, go on, Ben. Right. What about Marvell? Marvell, until very recently, have not released any v7 processors. So a lot of the common things out there, the Guru plug, the Dream plug, are still running v5. They have just started shipping some v7s, which should work just fine with ARM-HF as soon as people start testing on them. So in Debian, this is where we're up to. And I'll show, hopefully that comes out. So this is showing the status of the different architectures in Debian. And you can see all of the existing architectures are basically up at the top of the graph. This shows how much of the archive has been built on those architectures. We can see Herd bumbling along at about 70%. I can't see it ever getting beyond that. Sorry, minor dig. And back at the beginning of December, we see down here, there's 2 new lines joining in. One of those is S390X, which is a new port to the IBM Z-Series mainframe, but using, again, a new ABI that's now 64-bit. And that's the green line. And the red line that goes next to it, and now is well up into the 90% range, is ARM-HF. We've had some incredible success so far, basically based on the huge amount of work done by Konstantinos Margaritis, another Debian developer who works for Genesi, who also sell ARM-powered devices. Obviously they're keen to see this work. He did a huge amount of port work in the unofficial Debian ports archive. He and I have been working to transfer that over into the main Debian archive, and it's gone very well. We're quite happy. There's still a few things to go. We've still got bugs to fix. I've got a lovely one at the moment where Ruby or pthreads or maybe both conspire to cause test suite failures. LibreOffice has a few issues that stop us building it at the moment. We need to fix those. We've got some language bootstraps remaining. We need to bring up Common Lisp. The Mono developers are asking for help in doing a small amount of port work to make ARMHF work for Mono. And basically, literally just in the last couple of weeks, we've started migrating into Debian testing, along with the other architectures. So there's a very good chance, and we're really hoping that we're going to ship ARMHF with Wheezy. In Ubuntu, there have been 2 ARM ports. They only came into doing ARM work quite recently. The first one they did was ARMEL, but it's different to ARMEL in Debian, just to cause confusion. They have basically done version 7 EABI soft float, again with Thumb 2, but they've called it's just exactly the soft float version of ARMHF. In the last few months, ARMHF has also been bootstrapped in Ubuntu. They're up to a similar point as we are in Debian. Obviously, as we're quite close, the 2 teams are working together to get the same last few bugs fixed. Again, we're hoping that the next Ubuntu release, Precise Pangolin in April, will also ship with ARMHF. It will be lovely to get into that because that's going to be an LTS release. So, that's where we're up to. I'm not going to talk much longer because I'm getting bored of my own voice, don't about you lot. So, where's everybody else up to? Susa, who wants to talk? Pass it back.
Yeah, SUSE started their port effectively from scratch end of September. We're now sitting at just under 86% of the full distribution ported over, using ARMHF as our primary target. We do have a V5 soft float port sitting there as well, but that's not our focus. That's predominantly for people that have the likes of the Guru plugs and such like. So if anybody wants to chip in and move that along, by all means, come and join in. But yeah, no, we predominantly targeting V7 upwards, hard float. So yeah, we're slowly getting there. The biggest issues for us are predominantly the kernels, wide variety of them, with some spurious sources, and obviously accelerated graphics, and for that matter, even basic 2D graphics as a result of kernel issues are one of the issues as well that we're encountering.
Okay, Fedora? Anybody here know about Fedora ARM? Deathly silence. Okay, I'll chip in. I'm not a Fedora developer, never have been, but I have been following along a number of the other distros, including the SUSE and Fedora builds. Fedora basically at a similar kind of situation. They've got, again, 2 ARM ports, soft float v5 and hard float v7. Again, they're hoping to be able to get stuff into the next release. There's a lot of work to be done, not necessarily in terms of building for ARM, but also actually getting in sync with the rest of Fedora, because of course, you know, it's always a moving target. You never know until you get close to a release if you're actually going to be shipping with it. Any Gentoo folks around?
Yeah. Well, okay. Honestly, I'm not really the most active member of the ARM team, but I mean, being a source-based distribution makes things easier in some ways. And we have stages on the ARM v7, and we have ARM v5 based systems, and that seems to be working just fine. The number of keywords and the number of packages that are actually keyworded for ARM is increasing.
Cool.
So I see it kind of working. I even have unconfirmed reports of people running KDE. So
Cool. Oh, do you know, are they, the V7, is that soft float or hard float?
well, I'll try to figure it out. I don't know. I just have an OpenRADI Ultimate. So
Okay. Sorry? You can use both. Okay. Of course, yeah. Right. Right. I know the Mageia folks are quite interested in ARM, or at least a couple of their developers have been making a lot of noise, but I don't know if there's anybody around.
Yep. I know the actually now.
Okay, do you want to pass the mic forward? It's on.
I know some of the Arch Linux guys have ARM ports working. I think it's ARM v7, but not sure. They would have to tell.
Okay.
On FOSDEM, we are currently starting a v5 port, but we plan to do also ARM port.
Okay, excellent. So fingers crossed. You know, what we've been pushing, as I said, in Linaro and in ARM, which is to go for the hard float port. That does seem to be working all round. Android, yes, of course, is another interesting use case. We've had some contact with the Android folks. I mean, there's an Android team in Linaro as well, and they've been exploring building as hard float. Just for the sake of the extra performance, the Android team seem to be quite interested, but of course they have next to no interest in following standards for the sake of sharing binaries. You know, I'm sure that won't come as a shock. The thing about hard float is, again, I should explain, is it doesn't matter about what kernel you run. You can run soft float and hard float binaries on top of the same kernel. It's just entirely about user space interfaces. And that's the place where Android is so totally different from all of the other Linux distros that there isn't a huge amount of sharing going on. Ben?
So what is the expected lifetime of the V5?
Go on.
Just wanted to do a couple of questions. Firstly, what is the recommended lifetime of the V5 ports? Are they going to disappear anytime soon?
To be honest, it'll depend a lot on community support. I mean, in Debian, we're still running with V4T, and we have been for a number of years. We've got so many people out there with V4 and V5 devices that we're not going to... The plan is very much we're going to keep ARM-EL and ARM-HF going in parallel for the foreseeable. Well, exactly, as Wookie says, a lot of people have gone out and bought Shiva plugs with their own money. They're going to be very upset if we suddenly say, oh no, we don't care about you anymore. Oh, somebody's trying to ring me. Joy. In the other distributions, I guess it'll be a similar story. The people who've been out and bought, you know, the Shiva plugs, the Guru plugs, whatever, to be able to do their own small home servers based on those, well, of course they're going to want it to continue. ARM and Linaro explicitly, of course, are targeting brand new devices, and all of the Linaro member companies are more interested in V7 than V5. So that's why we've had most of the push has been for the hard float ABI. As we go forward, of course, I don't know, has anybody heard about ARM v8? Right. Has anybody not heard about ARM v8? Fine, there'll be some. Basically, ARM v7 is the last, so far, ARM ABI or ARM processor design that is only 32 bits. ARM v8 is the point where ARM will finally be producing a fully 64-bit machine. So you'll get all of the usual benefits of larger address space, potentially more registers, more instructions, all kinds of good things. And it's seen as critical as ARM moves into servers. The important thing about v8 is, of course, it'll also continue to run all of v7 instructions, and hopefully should be just as fast at running those as the previous v7 machines were. ARM-HF is very much the solution to running 32-bit systems. on V8. That's one of the reasons why we're standardizing it. We're even hoping that we might be able to get through LSB certification and have ARM added as an LSB architecture. It's not there yet, there's still work to be done, but we're hoping for it. Yes, do you want to pass the mic back, Ben?
So still about ARM v8, what if applications want to use more than 4 gig of RAM?
In that situation, well, they will. A single application using more than 4 gigs will need to be written to be V8, so it will need to be compiled to run, the new instruction set, the new architecture. In terms of systems where you may want more memory than 4 gig, but you're not necessarily bothered about the program running that, then the latest Cortex A15 processor includes virtualization extensions and LPAE, so you can have large amounts of memory available. Similarly to what Intel did before they went fully 64-bit, you'll be able to have many processes or threads all running with a reasonable amount of memory, but you'll be able to have one single machine supporting all of them at once. You want to pass the mic across?
So this is maybe slightly less of a distro-related point, but
Yeah.
since I'm here with Zen.org, I thought I'd mention that we've got Zen working now more or less on ARM. We haven't got any tool or guest support yet, but we do have a DOM0 that boots to a shell prompt, and we're expecting to get that stuff into our tree very soon, and in the next few months we should expect to have a working ARM proper port that you can run everything you like on. That works, however, only on hardware that doesn't exist yet, so we're slightly ahead of the curve. That's the virtualization extensions that Steve was just talking about.
Yeah, on A15. KVM, I believe, is meant to be up and running on A15 in models at the moment, but I could be wrong. The QEMU folks are also looking at A15 and virtualization and expanded memory. There's a lot of work still to be done there. Sorry? Yes, PVOps.
Well, actually, I mean, you say PVOps. We're talking about essentially upstream Linux kernels here. The changes you need to make to get it to run as a DOM0 are trivial.
Okay. Right. Do we have any other updates from any of the other distros I might not have thought of? Any other questions, please?
So I'm both a Debian developer and a Mozilla developer. So my interest is to know your experiences with testing. So one of the problems with ARM is that there are so many different levels and different socks and stuff like that. And for example, in Debian, I've had the problem that some packages wouldn't really work on ARM v4 while we're targeting it, and we're actually building on ARM v5, so we have some problem testing it to actually know if it works on ARM v4. And relatedly, at Mozilla, we are trying to get Firefox running on ARM v6. And while the builds we have run on ARM v7, they don't on actual ARM v6 because of fancy stuff like page coloring. So, so I would like to hear about your experiences on testing on various architecture.
Yeah, I mean, of course, the fun thing in Debian, the reason that we're still supporting v4t is, as far as I understand, basically the OpenMoko is the last v4t processor out there that people really care about. Unfortunately, it's also a really, really small machine where the prospect of building or running Firefox is scary.
It actually runs. Well, it used to.
Sure. I mean, I guess, are you Mike?
Yeah.
Yeah. I don't think we actually met before. But, of course, the problem is that building for V4 and testing on V4 are two different things. So while we can have the toolchain running on V5 and targeting V4, and we're happy it mostly works just fine, modulo the occasional bug, actually finding V4Ts that we can test on is very difficult. Equally, even more so, finding a V4T that's big enough to be able to do useful testing. I don't really have a solution to that. If you have any suggestions. And again, a similar thing with V7, V6. There are a lot of ARM v6 devices out there, but most of them are fairly locked down and built into mobile phones and so on. In terms of finding a generic accessible V6, it's not so easy. So yes, the Raspberry Pi is actually one of the very few that I'm aware of. The Beagle is V7. So of course, at the moment we've got the big split almost from V5 to V7. The Raspberry Pi is a V6 and is fairly well known. Off the top of my head, I mean, I work for ARM, but I couldn't tell you all of the V6 CPUs out there. It all depends on what the silicon partners have done. I don't know, Wookie, can you think of any? No, it's V5. Okay. There are a few SoCs, but actually getting hold of them to be able to do useful testing or whatever with them is difficult. I believe just about all of the Marvells until very recently were V5. I don't know of any Marvell V6s. Yeah. So yes, Mike, you have good questions, and I wish I could give you an answer. Basically, V5 and V7 seem to be the sweet spots in terms of building and targeting, just because of the sheer number of different SoCs available. It's the best thing I can suggest. I mean, to be honest, actually, quick show of hands, does anyone here have an OpenMoko? Does anyone here actually use their OpenMoko? Right, Wookie, he knows how to build his own stuff. Would anybody here care much if Debian stopped supporting V4T? 1, 2, 3, 4. Okay. Not that I'm suggesting we're going to do it. I'm just honestly curious, because it is a question that comes up regularly, as why are we doing it? Sure, yeah. Oh, yeah, wonderful. Okay, we will end up at some point in the future dropping V4T. I think we can guarantee that. We have another question at the back? Okay, can we pass the mic back? I couldn't hear that either.
So yes, as I was saying, there are quite a lot of devices running Cirrus Logic EP93XX SoCs.
Okay.
And those SoCs also have VGA display most of the time, so having a full-blown Debian can make sense.
Okay.
Now, what you can get as as an individual, it's just the simple machine SIM1 board or something like that. So if you drop it, I won't beat you.
Okay. Thank you. Right. Sorry, Rob? Oxford Semi have some V6s as well, apparently. Fine. They don't exist anymore, I'm told. Okay. Right. Do we have any questions about actually porting things to ARM? Yeah. Andrew.
Like I mentioned, one of the issues that we have with porting SUSE to ARM is the breadth of kernels for each SoC. What's the status of device tree for trying to flatten?
Ben seems to be keen to answer that.
I think there's a big, actually, the question is slightly wrong. It's not the device tree that's important. It's actually getting the kernel to build for multiple different systems, because then we got the V4, V5, V6, V7 problems, and we got a whole pile of SoC support which doesn't quite yet all exist happily together. I mean, Linaro have been doing a lot of work with the community in this, with trying to get it so you can compile a kernel, but the existing booting way should still work for the existing machines. It's just getting the kernel to support it. I mean,
Yeah. As we move forward on V7, one of the biggest targets for the Linaro kernel team is to have the single Z image that will boot on any V7. Frankly, being brutally honest, and I might get beaten up for saying this, it's probably never going to happen that we'll support all of them. But at least for the commodity devices that all of the current silicon vendors are pushing now, the landing teams are trying to get together to get, using device tree, you should be able to get all of those systems running on a single Z image. That is the holy grail. It's exactly where we want to get to, for example, for servers. We don't want to have 15 different kernel flavors to be able to support the machines, because frankly, that's a mess.
yeah, device tree produces a very useful thing of actually not having to keep changing your kernel, but the old booting method with a machine
Yes.
number is actually quite valid even for a multi-image kernel. So,
Yeah. I said I'm curious actually, has anybody else, actually being entirely selfish, has anybody else seen any problems with Ruby on ARM? No. Yay.
I'll just say I met a man last night who seemed a very keen Ruby developer who was remarkably keen to help solve this issue.
Okay,
so,
cool.
I think we should just talk to them.
Yeah.
Apparently there's all sorts of problems with Ruby threading, so it might not just be us.
Sure. Equally, the one thing that I was quite surprised to find actually was I could not find any pthreads torture tests out there available. There's a number of test suites available for testing different bits of pthreads and make sure it meets the spec. But in terms of doing really evil, nasty shit, like spawn 10,000 threads and have them do all kinds of things in the wrong order and make sure the right answers still come out, I'm not aware of any. Please, I'd love for one of you to be able to tell me I'm wrong and that there's one out there. Please? Oh, arse. Right, Wookie's mic doesn't seem to be working. Right, if Wookie says there was a person from Fedora wanted to talk to him about MultiArch. If so, he doesn't know who you are. Please grab him now because he's going to be leaving and running away in an hour. MultiArch is a big thing within Debian and Ubuntu at the moment. It's a major technical goal that we've been working on for far longer than it should have taken. But it is very much the right answer in the future, we feel, for supporting multiple architectures and maybe multiple flavors of multiple architectures on the same system at once. I know that I've had dealings with a number of the Fedora folks who are very keen on following the same path. Do we have any feelings on it from SUSE, Arch, anyone? I've seen that, yes. Yeah. Okay. Cool. So, yay. Well, okay, fine. If people would like to know more about MultiArch and why it's useful, there's a whole bunch of information on the Debian wiki, the Ubuntu wiki, the Linaro wiki, and generally it's good. Please do it. One of the interesting parts of ArmHF is that due to the existing EABI spec, ArmHF demands that at least some of the basic system is following the MultiArch conventions. I'll explain that slightly more in that the name or the path to the runtime linker, ld.so, on ARMHF and ARMEL is exactly the same. That is quite scary if you manage to mix them up, in that if you try to run a binary with the wrong runtime linker and potentially the wrong libraries with ARMEL and ARMHF, you won't necessarily know that you've got it wrong. It's not like if you're trying to run a Spark binary on an i386 where it'll just say wrong architecture, or if you're trying to run a 64-bit Intel binary on a 32-bit i386, where again it will tell you that you're trying to run an invalid ELF program. ARMEL and ARMHF are close enough that the programs will run, unless you're very careful, but just give you the wrong answers. Be aware of this. So what we've done for ARMHF is we have explicitly changed in the GTC configuration the path to that runtime linker, so that in the ELF headers of all the programs that you build for ARMHF, it will actually point, instead of to /lib/ldlinux.so.3, it will point to /lib/arm Linux GNU EABI HF /ldlinux.so.3. That is a major change. Be aware of it. Although you shouldn't need to be aware of it. Sorry, I'm confusing things. In that your system, if you're going to run ARMHF binaries, will need to have something in that location. But so long as either you're running a MultiArch system like Debian or Ubuntu, or you have a symlink to the correct linker in that path, your system will just work. We would love if the rest of the distros follow us and do MultiArch for the system as a whole, but be aware this is a place where if you're not careful, you might be bitten. Where are we? Quarter to... we are in Linaro, very interested. Oh, sorry, we have a question at the back. Mike? Mike's dead? Is it turned on? Is there a red light? Do you want to hold down the button?
Since you just came back to ARMHF, the
Yes.
benchmarks that you mentioned in the beginning, like on average 30% faster, was that done on your ARMHF versus the old ARMEL, or was it done on basically ARMv7, Neon, and VFP, and then just difference as in floating point versus integer registers, or was it just ARMHS versus ARMEL?
We have a mix of different benchmarks, I'm afraid. Direct benchmarks of most of this were done using Debian ARMEL against Ubuntu ARMHF at the time. There's work going on right now to redo all of those benchmarks to do directly, still v7 with all of the other enhancements, and direct just comparing ABIs. Watch this space; they're coming soon.
Okay.
In terms of, go on.
A quick question: does ARMHF require many libc changes? For instance, in OpenWRT we use usilibc a lot, and would it be a large effort to adjust it for HF?
In theory, just about nothing. The only thing you will need to do is put the symlink in place so that you find the runtime linker.
Okay.
Most of ARMHF, fundamentally the difference between ARMEL and ARMHF is just in the conventions of passing floating point arguments. If your program is doing nothing special, does not do anything particularly low level, it'll literally just be a recompile. If it works on ARMEL, it'll work on ARMHF. If you are doing something low level and horrible and grotty, and yes, I'm thinking of Ruby here, or ditto, there's bits and pieces of LibreOffice which do, there's a bridge in the middle called Uno, which needs to know huge amounts of detail about your platform and your binary formats, then absolutely those are the places where where people are going to need help to make ARM-HF work. If you rely on the compiler to get it right, it will.
Yeah, I
Touch
just
wood.
remember that with EABI versus OABI, there were quite a few differences that had to be taken care of in UCLibC, and it had to implement some stubs here and there that were not provided by libgcc, and I'm just wondering if something similar is going to come up for HF.
I don't expect anything like that. You know, existing EL is already working fine on V7 with exactly the same setup. ARM-HF is literally just the change of floating point.
Okay.
Right. Microphone forwards. Yes.
Boost Thread library has 7,000 lines of code of thread testing, and they are based on pthread, as far as I know.
Awesome, thank you.
Perhaps it's applicable.
I'll give that a try. And across here?
Which linker are y'all using?
Sorry? Both gold and the normal GNU link, you know, binutils linker should work. Again, there isn't anything particularly special at this point that they care about.
Which one did you pick?
We in Debian, we've just been following the same builds as for ARM-EL. So unless a package specifies one or the other, you know, it comes out. Right. Okay, Andrew.
Just a quick question with regards to the Linaro evaluation builds.
Yes.
Are all the source packages available for the likes of primarily the kernel, so that we can test our kernel builds using the same source as ones that work, so we've got a decent reference point to build against, rather than just doing a git checkout, right, okay, that's supposedly the tree that was used,
Sure.
etc.
Unfortunately, I don't think they are all available packaged in the same way that we might expect in Debian or Ubuntu. There's a lot of discussion going on about that right now. At the moment, the best way of getting Linaro kernel source is Git. And I wish it was different, but it's an ongoing debate. Sorry. So we have a whole bunch of people in Linaro whose job is to help with ARM knowledge and help porting software. Get very echoey. If you have any questions about ARM, you know, whether it's detailed tips on how to get the best out of the CPU if you're writing software for it, or how to port your existing software, especially so if you're involved in a distro and you're looking for help, guidance, whatever. Please, there's the cross distro. Come join us there. We try to have regular get-togethers at various events. I mean, like I said, this is part of what we're trying to do. We'll have another cross-distro ARM BoF at the Linaro session this coming week in California. If there's anything you want to know about, please ask. We might say we're not sure, but the chances are it's the best place you're going to find expert help. Unless there's any more questions, I think we're done.
In the Linaro project, what's your experience with platform support, driver support from the vendors, the chip SoC vendors?
It's varied. The Linaro members, as I said, TI, Freescale, and so on, they're all committed to providing better support, upstreamable support for all of their system-on-chip products. Some are further along than others, just because they've had more experience in the past.
Well, I'm asking because for some of the vendors, I don't see that happen. So we're into embedded systems, small company I work at, and we decided for one specific vendor because the vendor claimed he will provide anything put things back upstream and takes care of it, but nothing of that was true basically. And
That's a shame.
it's one of the largest vendor of ARM SoC, so that is really a shame. Okay.
We're trying. ARM as a company wants to be seen as a good open source citizen. You know, we've got lots of really good free software developers involved to try and help with that. One of the reasons for Linaro to happen is to help the rest of the ARM ecosystem do that. It's taking a while. Lots of what we have done already is starting to go upstream. I mean, there's lots of people in the room will have seen the various complaints from Linus over the last 12 months about what a mess the ARM part of the world is. We're working on that. We're working on, instead of just having the previous setup where most of your SoC vendors might never ship the drivers upstream, or were, to be honest, they try to put them upstream, but they were just awful code and would never be accepted. Part of the long-term goal is to get them to work together. So instead of having individual serial port drivers, like 25 of them, which all work identically, except for the tiny bit that doesn't, we're trying to get common core. It's taking a while. We've got really bright people on it. Fingers crossed we'll get there.
I was just wondering, at the point where you claimed that getting patches back upstream is one of the prime goals of Linaro, because that I've been told by that vendor directly that they don't plan doing anything like that. So it's
wonderful.
Weird.
Yeah, that's again. I've heard this from other people too. With a lot of the silicon vendors, it also depends on who you talk to. There's the whole big company syndrome where there might be 1,000 people all working in what we consider the right direction, but unfortunately you found one of the 100 who are pulling the other way because they think this open source thing is shit. You know, it happens. In the long term, really, we're trying hard.
Okay, thanks.
Okay. Okay, and one more question.
Earlier this week, Warren East, during the earnings report, said that ARM wanted to react or adapt to the large demand in free and open tools. Do you have any details on that? Is there anything in particular coming up?
Sorry, I don't get. We have quite a number of people in ARM already working on the free software ecosystem. So as well as I said, I've been working on ARM HF in Debian, Ubuntu. We also have a number of people who are working on not just improving ARM support in GCC, for example, you know, and the other tool chains, but also actively becoming part of the upstream. So we're doing the gatekeeper thing. We're doing the generally be good with the community. There's a lot of that going on, and the teams involved are still growing continually. We're hiring, in fact, if anyone's interested.
So that was just, in your opinion, a general reference to the Linaro efforts and no big thing coming up?
If there is a really big thing coming up, I'm afraid I don't know about it.
Well, so one other thing that's going on is that the Consumer and Embedded Working Group at the Linux Foundation, that used to be the CE Linux Forum, has been working on this thing that you've probably heard of, the Long-Term Stable Kernel Initiative. There's going to be an update on the progress of LTSI on the afternoon before the start of the Embedded Linux Conference, overlapping the tail end of the Android Builders Summit, out in San Francisco a week and a half hence or something.
Yeah.
And there's been lots of discussion going on with ARM and with various silicon vendors, in addition to the various CE companies. I don't actually know what the group is going to specifically be announcing in the way of progress that afternoon, but with the combination of Greg K.H.'s move to the foundation as a new fellow to work, among other things, on these stable kernel initiatives, I wouldn't be surprised if there isn't some sense that, you know, that's part of the swirl of increasing support for, because a lot of the CE working group companies' products are ARM-based, so I wouldn't be surprised if there isn't some correlation there as well.
Sure. Thanks. And I'm being told that we're out of time. Thanks all for turning up. If you do have any more questions, please contact me.